Welcome back. In an earlier video, I promised I would show you how I got those addresses for some Windows functions. And what I used was a program called rwin. So you can go on the internet and do a little search for rwin.c, and you will find this very simple C file. This was written by Steve Hanna. And if you go to vividmachines.com, you should find this file. It calls a couple of Windows functions load library for the name of a library that you passed in on the command line, a DLL. And then it calls get proc address for whatever you passed in as the second argument. And if it found it, it will print it out. That tells you for this version of Windows that I'm targeting, that is the correct address. So I've previously compiled this, and now I can run up a command prompt and I can go to that location and I can run the program, rwin. If I'm looking at an exploit, I can say this exploit involves a program that will load this DLL. So I know that this DLL will be loaded when I am running my exploit. If I want something very generic, there is a DLL that is always loaded, and that's kernel 32. That is required for anything to run on Windows. So I can say, what's in kernel 32? Well, there's a lot of good stuff in there. One of the functions is win exec. So I run this and it tells me, okay, here's your address right there. This is the address for my win exec function. And if you check back into the assembly code, you will see this is exactly the address that I used. I can do the same thing for my exit process. So I'll look in kernel 32 DLL exit process, and it tells me its address, 7C81CAFA. By the way, in some earlier videos, we said occasionally you might have trouble with addresses that have leading zeros, which can be problematic. Notice that these libraries never do. They tend to come from higher memory locations. I also have another pretty simple program for the sole purpose of testing shell scripts. So I can open up this program, and it's a pretty simple program. It has a main method here, int func, and here we are going to call our code. So we're essentially going to execute our code. So our code is stored in this big string. So we define a character string up here. And this is where you take the output from my script and you cut and paste it. So it's a pretty long line. I could shorten it up a little bit and put it on multiple lines, but for our purposes, it doesn't really matter. You can go ahead and compile this. It compiles successfully. And now, if I go to my command prompt, I can try to run it. Now recall that this shellcode would attempt to run the Windows calculator. So if everything is correct, the Windows calculator should appear as soon as I run my program. Test shellcode, and boom, it did, in fact, bring up the calculator. That's all you need to do to have some Windows shellcode.